So we're going to look at the second part for coordinate geometry, where we're going to look at the equation of the circle. Okay, and this actually comes from Pythagoras theorem, and you can see these two diagrams right here, where the first one is with the center 0, 0, and remember you are basing that whole equation off through the radius, right? So suppose this was the radius and that was the coordinate xy, then obviously that means that it has moved x coordinates to the right and y coordinates up. And with that, remember, because x and y are perpendicular to each other, then you can create a right angle triangle here, and you can use Pythagoras theorem to make an equation in terms of r. X squared plus y squared equals r squared, right? And quite simple. Secondly is with a different center. So when you have a different center, you can do the same thing with the triangle and the radius, but now the horizontal distance would be x minus a instead of the normal x, because you have to take it from this point right here, which is x in the x-axis, and this one, which is a in the x-axis, right? And the distance between them is just x minus a. The same thing for the y-axis. Then you do the same Pythagoras theorem thing to get the radius. So x minus a squared plus y minus b squared equals to r squared. And that's how the equation of the circle works in general. These are some examples finding the center and radius from the equation of the circle itself. So the first one, x squared plus y squared equals 4. Remember, the equation is x minus a squared plus y minus b squared equals r squared. And from that, we can get straight away that r equals to 2, because r squared is 4, and so that means r is 2. And obviously here a and b are both 0, right? And that's how we get x squared plus y squared. That means the center is going to be 0, 0. Okay. Second one, x minus 2 squared plus y minus 4 squared equals to 100. So again, r is just the square root of 100, which is 10. And then a is 2 and b is 4. That means the center is 2 and 4. If you do not remember that, then you can just equate each of these to 0. So x minus 2 equals 0, x equals 2, and y minus 4 equals 0, y equals 4. That's how you get the x and y coordinates for the center. Finally, this one right here, where you get, okay, x plus 1 equals 0 and y minus 8 equals 0. We get x equals to negative 1 and y equals to 8. That means our center is going to be negative 1 and 8. Then our radius is just going to be the square root of 12, which is 2 root 3. Then deriving a circle equation from the center and the radius. So if the center is negative 4, 3 and the radius is 6, again we can use the equation that we know of, x minus a squared plus y minus b squared equals to r squared, where a is negative 4 and b is 3. So x minus negative 4 squared plus y minus 3 squared equals to 6 squared. And here you end up getting x plus 4 squared plus y minus 3 squared equals to 36. That's going to be the equation of the circle right there. Deriving a circle equation from a diameter. A is the point 3, 0 and B is the point 7, negative 4. Find the equation of a circle that has AB as its diameter. So they tell you literally to sketch out the problem. So let's do that. We want AB to be the diameter. That means we have a circle right here. We have A right here. We have B right here. And B is 7, negative 4. A is 3 and 0. Then obviously the middle point is going to be the radius. So that means the midpoint between these two is going to be the radius. And to find the midpoint, you will just take the average of the x and the average of the y's. So average of the x, 3 plus 7 over 2 is just 5. And average of the y's, 0 plus negative 4 over 2 is just negative 2. And so that is going to be your center. So we currently have x minus a squared plus y minus b squared equals to r squared. We have that x minus 5 squared plus y minus negative 2 squared equals to r squared. Then remember, x and y are any point on the curve, right, as we saw in the first slide. And so we can take x and y to be any of these to get your r squared. Because remember, this comes from the distance formula as well. 7 minus 5 squared plus negative 4 plus 2, this is plus 2 right here, squared equals r squared. 7 minus 5 is 2, 2 squared is 4, negative 4 plus 2 is negative 2, negative 2 squared is 4 equals r squared. So we have r squared equals 8, that means r equals to 2 root 2. And therefore we end up getting x minus 5 squared plus y plus 4 squared equals to 8, because r squared. And that's going to be your equation of the circle from the fact that AB is a diameter. Next, the equation of a circle is actually in completed square form. What do I mean by that? If we had the equation of a circle that we saw from above, the format, and we expand that format, we will get something like this. This is expanding the first x minus a squared. This is expanding the second y minus b squared. R squared obviously stays the same. And then you can rearrange it and you can get x squared plus y squared minus the x term minus the y term, and then plus this final term right here, which is a constant term. And this you can put it as two different quadratic equation formats, right? One with the x squares and the x, and the other one with the y squares and the y. And so if you complete the square individually with the x's alone and the y's alone, you will end up getting this thing right here. So you are factorizing it. This x square and y square have to be in the same coefficient, and obviously there is no xy term, right? Otherwise it's not going to be an equation of a circle. The last term we can call it c, and we end up getting a rearranged version, which is this thing right here. And if we have this, we can find the center and radius straight away, where the center is negative g and negative f, right? So the middle term, divide by negative 2. Yes. And the radius is going to be g squared plus f squared minus c. And that's going to be the radius. And so if you have it in the expanded form, you can take the x term and the y term and divide by negative 2 for each, so that you have basically your 2gx divided by negative 2, which is negative g, and 2fy divided by negative 2, which is negative f, and these two will be your x and y coordinates for the center. Then you can take your g squared and your f squared, add them together, subtracted by c, and you will get your radius squared, and then square root that, you get your radius. Okay, this is the equation of a circle in the expanded form. Find the center and the radius of a circle, x squared plus y squared plus 10x minus 8y minus 40 equals 0. So in this case, this thing right here is the c, this thing right here is the 2fy, this thing right here is the 2gx. So we said if you want to find the center, you take the 2gx divided by negative 2 and the 2fy divided by negative 2, the x and the y terms. That means I'll just do 10 divided by negative 2 and negative 8 divided by negative 2. Here I get 4, here I get negative 5. So straight away my center I know is negative 5 and 4. Then if I want to find my radius, I will take the square root of g squared plus f squared minus c. That means 5 squared, which is 25, plus 4 squared, which is 16, minus c, which is 40. And that ends up giving us 25 plus 16 is just 41, plus 40, which is 81. So there is square root of 81, which is just going to be 9. That's going to be the radius of this equation, of this circle, the circle with this equation right here, and with this as the center. Next, there are these circle theorems that we do use in this section quite a bit. We did these in IGCSE. It's just sort of a recap, where firstly, if a diameter forms a triangle with the third point being on the circumference, so A and C is a diameter with the third point on the circumference, anywhere it can be, then that triangle is going to be a right angle triangle, and the right angle is going to be at the corner where the point is on the circumference. So this right here, this is in IGCSE. Secondly, a chord right? If you have a chord, any chord on the circle, a chord is just when 2 points are on the circumference and there's a line connecting them, then the perpendicular bisector of that chord, meaning you take the midpoint and the perpendicular line passing through the midpoint of that chord, that line, that perpendicular line, will always pass through the center. So there are some tricks that we do sometimes where we have two pairs of chords. So this is another chord right here. Obviously for this one as well, the perpendicular bisector will pass through the center. And so if we find the equation of this and the equation of this, then we can solve them simultaneously to find that center, right? So that's another trick that you can use. The perpendicular bisector of a chord always passes through the center of the circle. Lastly, the radius, okay, at a certain point on the circumference is perpendicular to the tangent to the circle at that point. Yeah, so 3 things that we have done in IGCSE. I don't think the middle one we have done. This is something new probably, but this is very useful in this section. Next, a circle passes to the points P -1, 4, Q 1 and 6, and R 5 and 4. Find the equation of a circle. So we have a circle right here where we have, let's just say R, P, and Q. So -1, 4, 1, 6, and 5, 4. Then what we can do is use that thing we just learned right now, where the perpendicular bisector of 2 chords will both meet at the center, right? So if you have this chord right here and this chord right here, then the perpendicular bisector of them both, this one right here and this one right here, will pass through that center. So what we want to find is the equation of these 2 perpendicular lines, and with that we can equate them to each other simultaneously to get that center, right? That's one way of solving it. Obviously there's a thing, another way that I can think of, where you can use the equation of the circle and then have like a triple simultaneous equation with 3 equations. Okay, but we're not going to go through that because that's a longer process. We're just going to do this one because it comes from the whole idea behind that circle theorem that we just did. So what we can do here is find the perpendicular bisector between these 2 lines. We have already done this in the previous coordinate geometry topic, where you take the midpoint, which is going to be 0, 5 in this case, between P and Q. This is P, this is Q, this is R. 0 and 5, and the gradient between P and Q is going to be 6 minus 4 over 1 minus -1, which is just 2 over 2, which is 1. That means the gradient of the perpendicular line is going to be -1, because m1, m2 equals -1, since these 2 are perpendicular. And so this is the first set, and the second set is going to be, let's just take 1 and 6 and 5 and 4, so Q and R. Center is going to be the midpoint between 1 and 5, which is just 3, and 6 and 4, which is just 5. And the gradient, 6 minus 4 over 1 minus 5, which is just 2 over -4, which is -1/2. And from that we get the gradient of the perpendicular line being 2, from m1, m2 equals -1. So we have these 2 right here. From that we can form the equation of both of these, where y equals to -x plus 5, because this is the y-intercept straight away. We know that because the x-coordinate is 0. The second one, we have to do some more things to get the equation of that line. So y equals to 2x plus c, where it goes to 3 and 5. So 5 equals to 2, 3 plus c, 5 equals to 6 plus c, and c will equal to -1. So y equals to 2x minus 1. And so we have these 2 equations. From that we can solve them simultaneously. So -x plus 5 equals to 2x minus 1. Solve these, so we get 6 equals to 3x, x will equal to 3. And from that we can get our y as well. Y equals to -3 plus 5 which is going to be y equals to 2. That means the center here is 3 and 2. Then from that we can get our radius squared from just plugging it into the circle equation. So x minus a squared plus b y minus b squared equals to r squared. Remember, a and b are just now 3 and 2 respectively. And we can take any point on the circumference, which is the xy in this case, and we can solve for r squared here. So let's just use 5 and 4. 5 minus 3 squared plus 4 minus 2 squared equals r squared. We get 2 squared plus 2 squared equals r squared. And here 4 plus 4, which is 8. 8 equals r squared. That means the equation of this circle right here is going to be x minus 3 squared plus y minus 2 squared equals to 8, which is r squared right here. Next, the line x equals to 3y plus 10 intersects the circle x squared plus y squared equals to 20 at the points A and B. Find the coordinates of the points A and B. Now remember, they are intersecting, and we did this in the first section where whenever you see intersecting, that means the x and the x are the same at a point, and the y are the same at the point. That's why they intersect, right? And so that we can instantly do is put this x into this x. So this thing right here, bring it here. We end up getting 3y plus 10 squared plus y squared equals 20. From that we can expand this. 9y squared plus 60y plus 100. Expanding this gives us this. Plus y squared equals 20. Then we get 10y squared plus 60y plus 80, bringing 20 to the other side. 100 minus 20 equals to 0. Then we can solve for y in this equation. We get y equals to negative 4 and y equals to negative 2. That means at these two coordinates of y is when the x's are the same. That means that's where the line and the circle meet. And from that we can find our x coordinate as well. Remember, we can use any of those two equations to find the x coordinate. Let's just use the easier one. 3y plus 10. That means 3 negative 4 plus 10. And for this one, 3 negative 2 plus 10. 3 times negative 4 is negative 12 plus 10 is negative 2. 3 times negative 2 is negative 6 plus 10 is positive 4. That means the two coordinates at which they intersect is negative 2, negative 4. From the first one, y is negative 4 when x is negative 2. The second one is 4 and negative 2. Y is negative 2 when x is 4. That means these are the two coordinates at which they meet. Then we have to show that the equation of the perpendicular bisector of that AB, that means remember this is just AB, and show that it passes through the center of the circle. Now what is the center of a circle? It is 0 and 0, and we get that from this right here. And so we just have to show that the perpendicular bisector of this passes through 0, 0. So let's find the perpendicular bisector of this. So for that we need to find the midpoint first. Let's just visualize it slightly. 4, negative 2 and negative 2, negative 4. We need to find the perpendicular bisector. That means find the midpoint first. Midpoint between this and this is just going to be 1. So the average of the x, negative 2 plus 4 is positive 2, divided by 2 is 1. And negative 4 plus negative 2 is negative 6, divided by 2 is negative 3. And this is the midpoint. And the gradient of the perpendicular line is going to be m1, m2 using the gradient of the line AB. And the gradient of the line AB is going to be negative 2 minus negative 4 over 4 minus negative 2, which is equal to positive 2 over 6, which is just 1 over 3. And from that we can get the gradient of the perpendicular line passing through it as well, which is known as a perpendicular bisector. And that's going to be negative 3 from m1, m2 equals negative 1. So we have the gradient being this, and the point it passes through being 1 and negative 3. And from that we can get negative 3 x minus 1 equals to y minus negative 3. This format we got from the mx minus x1 equals to y minus y1. We did this in the previous section if you seem a bit lost here. From here, what's left is we have to show that 0, 0 is on this line. And so we can substitute 0 in x and we see what it gives us for y. So negative 3, 0 minus 1 equals to y plus 3. Negative 3 times negative 1 is positive 3. So 3 equals to y plus 3, which gives us that y is 0. That means x, whenever x is 0, y is 0. And therefore, 0, 0 is on this line right here. That means this passes through the origin, yes. And so that gives us correct. And so currently, this is what we know about the circle, that there is a line AB that is a chord of that circle. And the perpendicular bisector of that chord passes through the center, right? And we knew that because of the circle theorem we just did. And so we got this. Now we see that the perpendicular bisector of AB, which is this dotted line right here, intersects at P and Q. Right? Then we're told to find the exact coordinates of that P and Q. So what we need to do first is find the equation of this line right here, which you already have done, because the gradient of the perpendicular bisector line was negative 3. And since the y-intercept is 0, the equation is just going to be y equals to negative 3x plus 0, because this is the y-intercept, y equals to mx plus c, right? And so we just get that y equals to negative 3x is the equation of the perpendicular bisector. Then that intersects the circle at 2 different points. And remember, when we talk about intersection between this and this, we just have to solve it simultaneously. So y is negative 3x, we end up getting x squared plus negative 3x squared equals 20. X squared plus 9x squared equals 20. 10x squared equals 20. Over 10, we get x squared equals to 2, which gives us x equals to plus and minus root of 2. That means one of the points is positive root 2, the other point is negative root 2. And from that, we can find our y as well. Because remember, y equals to just negative 3 times that x. So when x equals to positive root 2, we get y equals to negative 3 times positive root 2, which is just negative 3 root 2. Then when x equals to negative root 2, negative 3 times negative root 2, y will equal to positive 3 root 2. And so these are the coordinates of P and Q. Finally, we need to show that the line y equals to x minus 13 is a tangent to the circle x squared plus y squared minus 8x plus 6y plus 7 equals 0. Now for this, let's just visualize it firstly, right? And from this, we can find our center and the radius. The center right here was negative 8 over negative 2 for x, so 4. And 6 over negative 2 for y, so negative 3. And the center is 4, 3. So let's just visualize that circle right here. We have the circle where the center is 4 and negative 3. And what we are asking is this line a tangent? Obviously, this is show that means it is a tangent. So if this line was right here, y equals to x minus 13, then what we would see is it intersects at exactly 1 point. And that is a condition for tangents. And we saw this in the quadratics section as well. So if we solve this simultaneously, we should get just one solution for it, because it should have only one intersection. And let's see if that's true. So remember, to solve this simultaneously, we just put the y into the y, because those y's are the same. So that means we put x minus 13 into that y. We end up getting x squared plus x minus 13 squared minus 8x plus 6, x minus 13 plus 7 equals 0. We end up getting x squared plus x squared minus 26x plus 169. This is the expansion of this right here. Minus 8x plus 6x minus 78 plus 7 equals 0. And then from that, we can simplify that. So x squared plus x squared is 2x squared. Negative 26x minus 8x plus 6x is going to be negative 28x. Then 169 minus 78 plus 7 is just 98, and that equals to 0. Obviously, we can simplify this. Dividing by 2 on all sides, we get x squared minus 14x plus 49 equals 0. And solving this for x, remember this is just a complete square. That means this is just x minus 7 squared if we simplify it, which just gives us one solution, because this is just x minus 7 equals 0, which just gives you one solution of x equals to 7. And it having one solution tells us that it intersects at only one point. And if it intersects at only one point, we know that it's going to be a tangent, as per what we did in the quadratic section. And that's how we show it's a tangent.